At the heart of programming is the concept of repeating a task multiple times. A for loop is the most fundamental way of doing this. In this lesson, we're going to learn how to use for loops in R. So let's go ahead and get started. Here is our list of learning objectives. If you like, you can pause the video and read through these, but we're going to come back to them at the end of the lesson. For now, let's start by thinking about the packages we're going to use. So go ahead and load the following packages, making sure that they're both installed and loaded using Pacman. Let's start out with a simple example of using for loops in R. Suppose we have a vector of children's ages and we want to convert these into months. So let's create that vector of ages and years. We'll create a vector of the ages 7, 8, 9. So we use the C function 7, 8, 9. Now we can easily convert this to months in R just using the asterisk operator, which stands for multiplication. So ages times 12. And now we have the ages in months. But under the hood, what R is actually doing conceptually is running through a for loop. So let's write this out explicitly. So what R is doing under the hood is doing something like this. For each age in the vector ages, print for me the following age times 12. And if we run this, we see we get the same output here, 84, 96, 108. And what we have just done is we have just written our first for loop. Now let's think about what's going on in this for loop. Here we define age here as a temporary variable that's taking in each element in the ages vector. So recall that ages is a vector 7, 8, 9. And what we did is we said for age, for each age in ages, print this output here. Now note that we could have picked any name for this age variable here. It is completely random. For example, we could write instead of for age in ages, for random name in ages, print random name times 12. And we'll see this gives us the exact same output as above. Now, if the loop's content runs more than one line, you generally want to use curly brackets or braces to embrace those loop contents. For example, here, let's say we wanted to say for age in ages, first create an age months variable and assign to that age, let's use the proper annotation from R, age times 12. And then in the next line, we want to print out age months. So we're just splitting up what we have here into two steps. In such a case, you generally want to use curly brackets, one here on the for line and the closing one after the contents. And if we run this, we'll see that we get the same output as before. Now here is a diagram of the general structure of any for loop that you can pause and study to get a sense of what we just talked about. So it says for each variable in some iterable, some vector, or some sequence of characters, do a specific set of things in these statements within the loop body. Now here is your first practice question, hours to minutes basic loop. So try converting hours to minutes using a for loop. So start with this vector of hours here, 3, 4, 5, and you need to use a for loop to loop over that, multiplying it by 60 in each case, and outputting the result at the end. Now, as a side note, loops can actually be nested into each other indefinitely. So for example, here we're going to write a loop for I in 1 to 2, and then within that for j in 1 to 2, print I times j. Let's go ahead and try that. So for, and then we opened our parentheses, I in the sequence 1 to 2, we're going to print the value I. And let's just go ahead and run that and see what that looks like. So we print 1 and 2. But then within this for I in 1 to 2, we can also write for j, and let's not forget our parentheses there, for j in 1 to 2 as well. Okay. Now we're going to print I times j. And so this print here has access to each of the iterations of I and each of the iterations of j. Let's see what that gives us. It gives us the output 1, 2, 2, 4. Here's a table that tries to explain what's going on there. So we've created kind of a combination of I and j values. In the first case, you had I of 1 and then j was first 1, and then I again was 1, but then j moved up to 2, then I was 2, and j was 1, and I was 2, and j was 2. Okay? And in each of those cases, you get these outputs. So while this is possible in R, and sometimes you do need it, often there are ways to write code that's a bit clearer and easier to work with. Now let's think about a fundamental question, and that is, are for loops really useful in R? The reason this is a valid question is because R already has vectorized operations. It already has a way to repeat a task over many iterations. For example, consider the age conversion we've been trying to do. You don't need a for loop to do this. You can just type ages times 12, and that works perfectly in R. Importantly, this does not work in many other programming languages. Because R was built from the ground up for statistics, it works by default. Okay? Moreover, mostly in R, you are working with data frames and tidyverse operations. Okay, for example, instead of doing this ages times 12, usually what you have is you have a data frame that may look like this ages df here with a column called ages, and you would just type ages df. You would pipe that into a mutate call, create a column called maybe months, and give that the value of ages, okay, times 12, or age times 12 in this case. So this is how we usually work in R. So what's the point of this for loop stuff? Well, mostly for loops come up in two main situations. When you're trying to do operations on multiple data frames, and also when you're working with non-data frame objects like plots. So we're going to dive into these more realistic examples later in the lesson. For now, we're just going to focus on the simple toy examples to give you the basics of for loops. Another thing to think about is when should you use loops and when should you use something called function mapping. Okay, so often loop tasks can be replaced with custom functions, which you map across a vector or across data frames. But we're learning loops anyways because, first of all, they're easy to learn, they're easy to think about, and easy to debug from a beginner's point of view. So they're a very handy tool to have in your toolkit. With that information in hand, let's go ahead and keep thinking about the fundamentals of loops. Let's think about looping with an index. Okay. It is often useful to loop through a vector using an index, and an index is basically a counter for the current iteration. We're going to see what this means. So let's take again our default example of converting ages and years to months using an index, okay? And recall that we have this ages vector here of 7, 8, 9. And now let's try to rewrite this for loop, but now using indexes, all right? So first we need to create a sequence of indices. Indices is the plural of index. And what we're going to do is we're going to do 1, 2, okay, length of ages, okay, and that's going to create the sequence of indices here, 1, 2, 3, okay. So 1 to length of ages, let me put that here, okay. And then we're going to assign this to an object which we'll call indices. Indices, all right, assign that value there. Okay, now let's go ahead and use this set of indices in a for loop. So I'm going to write the following: for, okay, I in indices. Think of that as for I in 1, 2, 3, because indices has the values 1, 2, 3. I want to print the following: print, okay, ages subset I times 12. So ages square bracket I times 12. If I run this now, we see the same output again. All right, so we did 7 times 12, 8 times 12, and 9 times 12. Let's think about what's happening there. So I is iterating over the values in indices over 1 to 3. In the first case, I is 1, so we have ages, the first value of ages here, which is what, 7, and that gets multiplied by 12. In the second case, you have ages square brackets 2, and then ages square brackets 3, and so on. Now, similar to when we wrote for age in ages, this I value here, this temporary variable, can take any other random name. So we can change this to for random name in indices, print ages random name times 12. This is a bit hard to keep track of because we have so many different variables going on. But if we run it, we see that indeed it gives us the same output. Now, rather than write for I in indices, with indices being an external object you created earlier, it is actually more common to create your vector of indices within the for loop itself. What do I mean by that? I'm going to type here for, okay, for I in 1 to length of ages. Okay, remember that 1 to length of ages just gives us 1, 2, 3. There we print, all right, print ages I times 12. So this is a more common way to write this kind of for loop. Now, for loops like this are going to be quite helpful when we're working with multiple vectors simultaneously. What I mean is for loops that are indexed in this way will be helpful for multiple vectors simultaneously. Another thing to mention is here we've been putting them all on the same line, but of course you can also write it like this, okay, with the curly braces here embracing the inner section of the loop. Now here is another practice question for you, similar to the loop you wrote before to convert from hours to minutes. Write another loop, but this time write it using indices. So for I in length 1, or for I in 1 to length hours, okay, print out your vector of, or your output of minutes. Now, as a side note, the function seek_along is a shortcut for creating a sequence of indices, and it's equivalent to 1 to length. Okay, so for example here, let's type here 1 to length, 1 to length, whoops, 1 to length ages, and let's type also seek_along ages. Now, if we run this first line, we get 1, 2, 3. If we run the second line, we also get 1, 2, 3. I tend to favor the first one just because I don't want to need to add another function for such a simple task. Now, as we said, indexing is going to be useful for looping on multiple vectors. Let's go ahead and see now how to loop on multiple vectors. Okay, so consider these two vectors, ages 7, 8, 9, and heights in cm 120, 130, and 140. Let's run those to define both of them. Now we can loop through both of these using the index method, and all we're going to do in the loop is print out the value of age, 7 for the first person here, and the equivalent value of height, 120 for the second person, then 8, 130, and 9, 140. Let's go ahead and do that. So we type for I in 1, again, to length of ages. And what we're going to do here now is print, first of all, define an object here, age. Age is going to be ages, subset I. Height here is going to be, hopefully you can guess, heights, okay, subset of I. And in each case, we print out the value of age and the value of height. Hopefully you understand what's going on here. First, we're going to have 1, so age is 1, and we'll pull that out. That's going to be 7. Then we'll have heights 1 there. We'll pull that out as 120, and we'll paste them together, and then 2, and so on and so forth. Let's go ahead and run this loop and see what we get. As we can see, we've now combined here 7, 120, 8, 130, and 9, 140. As I just explained, in each iteration, we have I as the index. We're extracting the ith element of each vector here, ages and heights. We paste them together, and we print the result of that. Now, we could also just write that for loop above in this way. So we skip assigning age and height and just use it directly in here. So this will be ages 1 and height 1. And if I run this, you see we have the same output as last time. Now it's time for a practice question for you. You're going to use an indexed for loop to calculate BMI. So go ahead, pause the video and try that. Now let's think about storing loop results. Usually you want to store the loop results that you are outputting rather than just printing them as we've been doing so far. So an example here is going to be, again, our default converting ages to months. So here's the loop we had before. We have ages 7, 8, 9, and we just print these outputs. But what if we want to store this information in some kind of data structure like a vector? What we're going to do is we're going to create an empty vector into which we will put the results. I'm going to call the vector, in this case, ages months. And the function we're going to use is called vector. Okay, very nicely. And it has two main arguments, mode and length. We'll start with mode. mode equals numeric, because we're going to be storing numbers in there, ages and months. And then length equals, what length do we want? It should be the same length as our input vector, which is those ages. So we just do length equals length, which is a function in R of ages. Okay, and we can put a comma here just so it's more readable. Let's define that vector now. Okay, and we can peer inside of it, ages, months, and we see it's just an empty vector with 3 values, all zeros. Now, how are we going to store values in this vector? Let's go ahead and see. So if you wanted to store a value inside of ages, months, let's say we wanted to store the value 99 in the first element of ages, months, we do the following. Ages, months, first element, 1, and we just back assign 99 into that, okay? And let's say we wanted to assign 100 into the second place. We just have ages, months, 200. And now we can inspect the output of ages, months after running all of that code above. And we'll see that those assignments have been successful. We have 9900 and 0. So what we're going to do then is do these assignments within the for loop. So let's go ahead and execute the for loop and store the results in ages, months. Okay. So first we go ahead and we create ages, months, which is the following, I've forgotten how to type, the following vector. I'm going to type numeric, and I'm going to type length of ages. Here I'm skipping the mode equals and length equals because that's not super necessary in this case. Let's remove this comment so it's a bit easier to read. Then we're going to write now our for loop. So for I in 1 to length of ages. Okay, we open our braces here. I'm going to say ages ages months I, okay, is going to be what? The value of ages I times 12. It's a bit hard to think and type, but hopefully I think that's correct there. All right, let's go ahead, run it, check the value of ages, months, and then we'll think through what's going on there. Make sure you're typing this code along with me. Okay, so we can see that the value of ages, months here is 8496,108. Let's think about what's happening here. So first we define this empty vector. This empty vector here, ages, months, okay, with 0, 0, 0. And then we go here for I in 1 to length ages, which is just 1, 2, 3, 1, 2, 3. Okay. First I is 1. We take the first value of ages here, which is 7, times 12. We store that in ages, months, the first value. Then we have ages 2 times 12. We store that in the second value of ages, months, and so on and so forth. Hopefully that is clear. Now here's a practice question for you. You're converting height in centimeters to meters using an indexed for loop, and you need to store that in a vector. One thing to watch out for is to make sure that the object into which you are storing your output is created outside of the loop, okay, in order to save your iteration results. What do I mean by that? Here again is our same loop that we've been using, ages. We have the vector of ages, and we're trying to store each output, so ages I times 12, ages 1 times 12, ages 2 times 12, ages 3 times 12, inside of ages, months. But notice what we're doing here. Try to think about what the problem is. If I run this, you can see that the value of ages, months is 00108. Do you see what the problem is? The problem is that we've defined ages, months inside of the for loop. And so what happens is that on the third loop, okay, we create a new vector of ages, months. Well, on each loop, we create a new vector, ages, months, and it's empty. And so only the third value is actually kept. So you have to make sure you keep this assignment here outside of the loop, so it doesn't keep getting rewritten, overwritten each time you run the loop. Now that we've fixed that, we have the proper output. Now here's another side note. If you are in a rush, you can also initialize your vector with the C function. So instead of typing vector, numeric, length, blah, 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 you can just type ages, months here is equal to C. And if we run this, we can see that it has the value null. And we increment it, or we fill it in as normal. So if we run this, we see it gives us 8496,108. And even simpler, within the for loop itself, you can append values also using the C function. What do I mean by that? So we're going to take again this whole set of code. Okay. And instead of ages months I is ages I times 12, you can write the following. Ages months is equal to C of ages months. Okay. And then, whoops. And then ages I times 12. Ages subset I times 12. Okay. So let's first of all run this, make sure it works, and then we'll think about what's going on there. Okay, we can see that it works. So what's going on there is, first we initialize an empty vector, ages months, and then when I is 1, okay, the C function combines that empty vector, null, with ages 1 times 12, okay, which is 7 times 12, and then it stores that in ages months. Then when I is 2, we run that loop again. But now there is already a value inside of ages months, and that is the 84. But because we do C of that original with the new, we can increment that that set of values. Let's try to think of it in a simpler way. If I do C, let's make a new vector. Let's just call it number, and let's assign to number the value 9. Okay, whoops, 9. If I run that now, you can see that inside of number is the value 9. If I do C number and then 10, that gives us 9 and 10. Okay, and I can reassign that now back to number and print number again. And you see now that number has the value 9, 10. And you can keep doing this to grow the value of that vector. So this is an easy way to write your code. However, it has one main downside, and that has to do with performance. So it's generally discouraged because in both of these cases, this one and this one, R does not know the final length of your vector. You don't tell it, hey, this is going to be a vector of length 3 or of length 5. And so what it's doing is it is internally reallocating memory each time. This has to do with the specifics of how R works as a programming language. So when you have large vectors, this turns out to be quite compute expensive, but for quick analysis, it's probably fine. Now let's think about using if statements within loops. So if statements can be integrated into loops in R and are often integrated into loops in R. Let's think of an example. Let's say we want to classify ages as child if the person is under 18. Let's see how we would do that. So first we define this vector of ages. Let's call it agevec to distinguish it from our other vector of ages. Okay. And we're going to try to write the following for loop here. For each age in ages, or in agevec rather, if the age is less than 18, we want to print the value child. So let's go ahead and write this for, open parentheses, okay, age in agevec. We open our braces there. If, and after the if, you put your parentheses, similar to for. If age is less than 18, what do we want to do? We want to print the value child. Okay. Now, similar to with the for loop, with the if statement, we can either put this on the same line if it's a single line command, or if we have multiple lines, or if we just want to be clearer, we can put it on a new line and use the curly braces there. So let's go ahead and run this and see what we get. Okay. So we can see it prints child 3 times for the first 3 children, 2, 12, and 17. So like I said, you can use curly braces for clarity, or if you need to add more lines of code under the if statement, it's often a good idea to use curly braces. For example, let's say we want to put these 2 things inside of the loop, inside of the if statement specifically. What we can do here is let's copy this and replace the print child there. Okay, so you can see we have 2 things now we want to do if the child is under 18. And it would be a bit ugly to try to put these both on the same line as the if statement. So we make sure we have the curly braces there. Let's run this and make sure that it works. Okay, we can see for each age we're doing processing, child age 2, and so on. Now going on with our if statements, let's add another condition with else if that will classify whether the child is a regular child or a teen based on their age. Let's go ahead and write this in. So we're going to try to add in here. This was our original for loop with the if statement here for age in agevec. If age is less than 13, print child age. But now instead of 18, now we have 13. and we add a new if statement right after this closing brace here, this closing curly bracket. We'll say else if. All right, that means after we evaluate this one, if it's not true, then go to the next one, else if. Okay. Let's see. No, first of all, else if with the parentheses here, age is going to be greater than or equal to 13. Greater than or equal to 13. And age is less than 18. Okay. We use the and here because age is only ever going to be one thing. Okay. And because age is going to be one value, and is the special and operator for singular values. If we use this and here, this is a vectorized version. Anyways, we use and here, and then we're going to print teen. So print paste child teen, age h. And since all of our spacing is messed up, I'll highlight all of my code and do Control Shift A. That doesn't do anything in this case, so I'll just delete those lines. All right, so now we have our final for loop. Let's run this and see if it works. Perfect. So we're classifying them as either children or teens. Let's add one more step to the for loop with if statements. We'll add a final else statement for other ages, classifying them as an adult. So let's go ahead and copy all of this. And then we're going to add one more else statement here. So just else. Okay. And this will capture everything that is not captured in the first two if statements. We say else print, paste. I'll just copy this line maybe in the interest of time. We type adult, age, and we run this. And now we have our final vector now, or final output of 5 different values. Remember that our age vec here had 5 values, and we have an output for each of those. Now you may want to store these values in a vector using an index-based loop. Let's go ahead and see how to do that again. This is something you've already learned, but let's apply it to this if for loop. So we're going to refactor this loop above, storing the values inside of an object called age class. So let's paste this loop here. We define first of all age class as a vector, and this is of mode character, because we're printing out these characters here, of mode character, and length of age vec. We can delete these comments so that it's a bit easier to see the code. Okay. Then, instead of just printing this value here in each case, what are we going to do? We're going to say age class I, okay, is, and we paste child age h. Actually, instead of age in age vec, in this case, we want to do for I in 1 to length of age vec. So now instead of going through the ages themselves, we're going through 1, 2, 3, 4, 5. And this age here is going to be, we'll take the ith age, the first age in the first case, then the second age, and so on. So let's replicate that across all of this. So square brackets here for each value of h, the ith age in each case, okay? And here we're gonna again store this in age class I, print, not print, but rather paste, okay? And the very last one here, we will paste it instead of printing it, okay? And as you can see, that's a lot of code or a lot of little syntax things, and it's easy to make a mistake. But these days with ChatGPT and so on, your mistakes can be easily fixed. So let's go ahead and run this and see if we get a valid output. I'll just highlight all of this and run that separately. Okay, oh, there's a mistake. If missing value were true or false needed, what mistake have I made? Age vec. We have 4 values there for I and 1 to length age vec. Sorry, I'm using age here instead of age vec. It should all be age vec. Okay, I see the problem. All right, I'll leave this in the edit just so you can see the sorts of mistakes one can make when writing these. Okay, so age vec, remember, is this thing. All right, and we're trying to pull out each successive element of it. So let's run this one more time. And now it runs successfully, and we can check the value of age class. And we see it is the stuff that we used to print before, but now we want to store it in an object age class. Now here is a practice question for you. This is a bit of a complex practice question. We want you to classify temperatures in this vector body temps based on the following rule. If it's below 36, hypothermia. If it's between 36 and 37.5, normal. Above 37.5, fever. Okay, you're going to create a class of empty vector, use index-based looping here, and store it within your for loop using if-else logic. Okay, and here, here's the kind of output we want. 35 degrees C is hypothermia, 36.5 is normal, and so on. So go ahead, pause the video, and try that out. Okay, so now you have the very basic elements of how to work with loops. We've been looking at these toy examples of classifying age and so on. Let's now go and look at the actual big tasks, the kinds of things where loops will actually be useful for you. So we're going to try to use a for loop to generate multiple plots for different groups within a dataset. Let's see how to do this. For this, we're going to use the strep-TB dataset from the medical data package. And our goal is going to be to create category inspection plots for each improvement group in this dataset. The dataset has information on how improved people were following treatment. So let's take a look at medical data strep-TB just to get a sense of what this data looks like. It has each patient ID, whether they were in the control arm or the treatment arm, their baseline condition, and then how much they improved in this radiologic 6M variable there. Okay, so here's what we're going to do. We'll create just a single plot for the first radiologic treatment group. We say filter, or maybe not the first group, just a random group. Radiologic 6M is equal to the 6 considerable improvement group. That means group 6, which is considerable improvement. We do a pipe. And then from the inspect df package, hopefully you remember this package, we pull out the inspect cat function, and then inspect df, show plot. I'm putting the name of the package here since we haven't used this package in a long time. And we put all of this into an object called a cat plot. But first of all, let's print it to see what this looks like. Okay, so if we print this, we see we get this very nice categorical plot. We filter to only those in the 6 considerable improvement group in the radiologic 6M variable. And we can see the distribution of their different variables, whether they were in the streptomycin group or the control group, whether they're male or female, and so on. So what we'd like to do now is replicate this for all the different 6 groups and store all of this information inside of a single list. So let's see how we can implement such a for loop. Okay, so the first step is going to be to identify the unique values of this vector here, the radiologic 6M group. And we can do that simply with the unique function. So we take medical data, and strep-TB, specifically the radiologic 6M variable of that. Okay. If we run this, we can see it's just a vector of different character values, or maybe that's a factor, I'm not sure. And we're going to take the unique values of that. So unique. All right, and we can see that there are these 6 unique values, and indeed it is a factor based on this that we can see there. So we store that in this object, radiologic levels 6M, and we're going to use that in our loop as follows. First, we initiate an empty list object where we're going to store the plots that we're going to create. So we do vector mode list, and the length is going to be the length of the number of levels, the length of radiologic levels 6M. So we have now this empty list. If we try to print it, you can see it's 6 null values. All right. And what do we do next? This is an optional thing. We can set the names of these list elements to the actual names of these radiologic levels. So to do that, we do the following. Okay. We say names of catplot list is radiologic level 6M. All right. So remember, catplot list at the moment is empty. And so if we check its names, we see we get nothing, null. And radiologic level 6M is this vector with 6 values. So we just run that like that. And now catplot list has 6 Still empty elements, but each of these is named. And this will make it easier to pull out values from the list later on. Now let's put all of this together into our final loop. So here we have a bunch of scaffolding code. I may actually delete a significant proportion of this code, all right, just to show you the process of copying and pasting that in. Okay, so we're going to say now for I in, okay, 1, 2 length, 1, 2 length of radiologic level 6M. Actually, in this case, since we're going to be storing in a named list, then we don't need for I in. We can say for level in each of the levels. For level in each of the levels. We're going to take this thing that we did here and put it in our loop. But instead of filter this equals 6 blah blah blah, we say filter that is equal to level. Okay. And all we have to do left, the last thing we have to do is store all of this inside of the cat plot list. So maybe we should also define cat plot list up there. Cat plot list level is cat plot. Okay, let's pause and think about what's happening here. So what this one is going to do is for each of these levels, for each of these radiologic improvement levels, it'll take first of all level equals 6 considerable improvement, and it'll filter strep TB data to just that level and make the plot, store it in this object. Then it'll take cat plot list level 6 considerable improvement, this one here, and store that cat plot in there. Hopefully that makes some sense. If you still don't understand it, pause the video and think through it on your own. So let's go ahead now and run this loop. And it seems to have worked. Let's see how we can examine the actual internals. So we can access a specific plot that has been created using the double bracket syntax, as I had shown you before. So here we can try a cat plot list of 6 considerable improvement. Let's pull that in here. All right, and we can see our plot there. Let's try some other level. I don't remember what the levels were. Let's print our radiologic levels. Let's try maybe 5 moderate improvement. Okay, perfect. We can see 5 moderate improvement, and we have a different chart there. And to display all the plots at once, we can just call the entire list. But I suspect if I tried to print that here, the output won't look so nice. Okay, actually, yeah, you can see all the different values of the list. Okay, so hopefully this is clear in terms of how that for loop works. Now here is your final practice question. You're going to visualize TB cases from the tidyr package, specifically the WHO2 dataset. So let's prepare this data here using this code and see what is inside of TB child cases. You have the country. A number of countries, you have the years, and you have the number of TB cases that were recorded in that year, the number of TB notifications amongst children specifically. Okay, so your task is going to be to fill in the template below to create a line graph for each of these countries using a for loop, and you're going to store those different plots inside of a named list called TB child cases plots. Okay, so go ahead, pause, and try that out. So congratulations on getting to the end of this admittedly very long lesson. Here's our list of learning objectives. See if you feel like you've mastered each of these. So the hope is that by the end of this lesson, you now are able to explain the syntax and structure of a basic for loop in R. Okay, use index variables to iterate through multiple vectors simultaneously within a loop. Integrate if-else conditional statements within your loops. Store loop results in vectors and as well in lists. Apply loops to actual real-world tasks like analyzing multiple datasets and generating multiple plots. And finally, that you can also debug your loops by isolating and testing single iterations. So this lesson has delved into for loops in R, both the basic syntax and applying it to realistic data manipulation situations. Hopefully you are now feeling more confident in applying loops in your daily workflows. Keep practicing and keep coding, and you'll get better and better with it over time. For now, I'll be signing off, and I'll see you in the next lesson. Bye bye.